Okay, so we've talked a lot about naming compounds. Now we're going to start to actually get into reactions. What is a reaction? How can we tell when a reaction occurs? And the different types of reactions. So this will be a lot of the rest of our chemistry unit. So we're in like a new chapter. So if you follow along at all in your textbook, we're in chapter 3 now. And kind of this two-part lesson is going to apply to page 84 to 93. So it's a good, like your textbook explains things well. So if you need an extra hand with that. So a chemical reaction has taken place when one or more new substances have been formed. Now when we talk about chemical reactions, we look at, we have two different terms to describe the beginning and the end. One is a reactant, so these are substances that undergo a chemical change. So this is like, if you think about a reactant, this is at the beginning, or what you start with. Okay, and then a product, so you produce something, is the new substances formed. So we think about things, so this is like your result, or what you have at the end of the reaction. So we start with reactants, there's a chemical reaction, and we end with products. All right, so how do we know if there has been a chemical reaction? And this is when I would ask you, and some of you will put your hands up. So just think in your head, when would I know that there's a chemical reaction? Well, if there, say, is an odor produced, so you can smell something, or what if there's a color change? You notice when you put bromothymol blue into the acid, it turned like a yellowy color. That means that there was a chemical reaction that occurred between the bromothymol blue and the acid. Also, if we have formation of gas, bubbles. So when you had your acid mixed with and you put your magnesium strip in, and you got bubbles, that was a chemical reaction. And specifically, we produced hydrogen gas when we did that. Also, if you form a solid, this is called a precipitate. I'm going to show you lots more about this at the, after kind of we go through this more. When we start doing reaction types, we're going to do lots of precipitates. Also, we can also have energy changes. So if there's a sound produced, or temperature increase or decrease, and we'll talk about this more, it makes light, like a fire burning, okay? So there's light given off too. Or if electricity is produced. Now also keep in mind that energy changes can just happen, say, if you're melting an ice cube. But melting an ice cube isn't a chemical change, it's just a change in state. So we can have energy changes with changes in state, but we would call this a physical, I have it right here, a physical change, okay? So physical changes can have energy changes, but there's not chemical. All right, next one. So now you can do this type of, do these questions, looking at the change and seeing if it's chemical or physical, and then explaining why, okay? So you can do that after the lesson. All right, so now this is kind of the second part. So, did I do the whole thing? I just want to double check. Yep, okay. So now we're going to specifically talk about compounds and if they're soluble in water. So in the lab, you figured out that we were testing salt water and sugar water. So it's sodium chloride aqueous and C6H12O6 aqueous. Now, ionic compounds, when we start with them, are solid. So when you look at just salt, it's a solid. But some compounds, some ionic compounds when mixed with water, will dissolve, like salt. If a compound can dissolve, we call it aqueous. So in your lab, you should have written NaCl aqueous for your identified solution, because they were all solutions. Now, when most ionic compounds are dissolved in water, like most ionic compounds can, what happens when they dissolve is that the cations and anions separate and they can move around freely. So it's like the Na plus is in the aqueous and the Cl minus is also in the aqueous. So they're floating around, which means that their electrons are exposed. So that's why they can produce electricity, or not produce electricity, but they, when you put the voltmeter in, you get a conductivity reading. And that's why, it's because they separate and the electrons can flow freely. However, some ionic compounds don't dissolve well in water. They won't, no matter how much you stir or heat it up, it will just stay a solid and the water won't dissolve. If a compound cannot dissolve, we call it a solid. So if it doesn't dissolve, it is solid. Oh, I know what I wanted to say. Yeah, solid, and that means that it is not soluble or insoluble. Soluble. Okay? So when something cannot be dissolved in water, it's insoluble or not soluble or slightly soluble or just solid. So let's add that here. When something can dissolve, it is called soluble. Then we put the aqueous with it. Now, sometimes, and I'm going to show you in a minute how you tell which ones are which. Now, sometimes, if two solutions of ionic compounds are mixed, their free ions may react with each other to produce new substances. If the new compound does not dissolve in water, a solid, use a blue color, a solid is formed, which is called a precipitate. Okay? The production of a solid indicates that a chemical reaction has occurred. Now normally I would show you an example of this, like do it together as a demo, but since this is virtual, I will just wait until I can see you in person and then I will demo it. So maybe on Friday, and if not on Friday, the next week for sure. We'll do this a lot together. So how do you tell if something is going to be soluble or not? Well, we're going to use a solubility chart. So now, Mr. Grant, you can hand out the solubility charts. So they would look like this. So this is a photocopy of what you will have in your data booklets, so you get it from your data booklets too. Okay? Just want to make sure my wording is the same as yours. All right, so this is our solubility chart. So we're just going to rewind to back here, and we'll explain how to use it, and then I'll show you some examples. So first, you locate just one of the ions in the compound on the top row. So this is the top row. So you look at your compound and you just pick one of these that is from your compound. Then the second thing is look down that column of the table to find the other ion. So say, for example, we're still using sodium chloride. So sodium chloride is NaCl. Okay, so I look at this top chart, and can I find either Na or Cl? Yeah, I can actually see both. Let me double check. Now, one point, you don't have the exact same thing as mine, but on your chart it says group 1 ions here. It says group 1 ions. So you need to remember group 1 applies to hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Okay, so when it says group 1 ions, it means all the rest. Okay, let's say we picked chlorine. So chlorine is in our compound, so I picked chlorine. So that's in the top row. Then you go down that column to find the other one, so to find sodium. Now here it says most, and then it has a couple others listed. Yours doesn't have mercury here, I think, and it has palladium there too. But anyways, so our sodium is not in this column, so it must fit in with the most. So sodium must be a part of the most. Okay, so that's the second step. So we found one of the ions, then we found down the column where the other one would be. Okay, the third step. If the other ion is found in the very soluble category, the compound is soluble in water. So remember, we just talked about that soluble means that it dissolves. So then, if it dissolves, you give it an aqueous for its state. Okay? For the question of, is it soluble or not? Okay? Even though it can be solid at room temperature, we're talking about if we tried to dissolve it in water, would it be? Now, if the second ion is found in the slightly soluble, okay, so that means not very much, or insoluble. Okay, so slightly soluble, they're just kind of saying it's not very much, so that's kind of insoluble. So it's not soluble in water and should be given solid. So the solid state. Because it won't dissolve, it will still stay. It will not dissolve in the water, or it will form a precipitate. If it's like a new compound. But again, I will give you lots of examples of that later. So here is that chart. Now, let's do a couple examples to get you kind of rolling. So let's say I have strontium hydroxide. So what if I had strontium hydroxide, OH2, okay? So strontium hydroxide. So there's a strontium ion and there's a hydroxide ion. So up here, which one can I find? Well, there's a hydroxide. Awesome. So then I go down the column and look, strontium is in the very soluble section. So then my final answer, if I was to say is strontium soluble or not, is SrOH2 aqueous. So it's solid at room temperature, but if I tried to dissolve it in water, it would. Okay? And sorry, I should finish this one too. Sodium chloride also fits in the very soluble category. So if I was being asked, is sodium chloride soluble, then I would go NaCl aqueous, because it is. So let's do one that's not soluble, perhaps. So how about, let's do calcium sulfate. So calcium sulfate. Okay? So I have a calcium ion and a sulfate ion. So you go to the top, you look. Okay, is there a calcium ion or a sulfate ion? There's a sulfate. Great. So now you go down the row and you look for calcium. Well, here it says most, but I'm going to double check down here to see if it's in that category. Oh, so there are some exceptions, and calcium is one of them. So since that matchup was in the slightly soluble section, calcium sulfate is a solid even if it's dissolved in water, because it cannot dissolve. So even if you tried to put calcium sulfate in water and dissolve it, it wouldn't work. It would just stay as a solid. So that's how you do those ones. So I'd like you to try try doing this table. So what I want you to do is you're still practicing your naming and putting your formula in, because this should be getting quite quick by now. You should be getting very familiar with your periodic table. So do the naming and the formula just like normal, and then say, is it high solubility or low solubility? So high solubility means that it would be aqueous, and low would mean that it's solid. So in this column, write down the state, if it's aqueous or solid, if it's dissolved. Okay? So that's what I want you to do. So we are picking up the pace quite a bit. I will be moving on to the next part of this lesson tomorrow, and I won't have any time to do this. Probably not, because we have some activities to do tomorrow for the lesson that I want to teach. So this will be due then for Monday. Okay, so please make a note of that this is due on Monday. Okay, if you have questions about it, it would be good to ask in the morning more time, because I'm still going to try and take a couple of your afternoon more times, because we're getting kind of behind. So that's it for today, but I would be happy to answer questions about this if you have some trouble. But again, it would be best if you came in the morning, because I'm usually not very busy in the morning. So I hope that you have a great day, and I will see you tomorrow.